Alrighty, in today's video, we're going to be talking about 7.4, logarithmic properties and models. A couple of little equation reminders. Um, the book talks about the continuously compound interest, but we didn't see it in the last section, and I don't see it on your homework on this one. But just in case you ever do come up on it, compound continuous is going to be, a lot of people remember it by saying A PERT, but it's A equals P times E raised to the RT. I didn't see this on your homework, and I didn't see it on your last one either. But the big ones for today are your log properties. So in the last section, we saw some things to help simplify. Now we're going to be expanding and condensing logarithms using these three rules. Rule number one is the product rule. And it basically just states if you have a logarithm in which you are multiplying terms inside, we can separate that into a addition problem. So this would be log of x plus log of y. So this would be condensed. This is the expanded form. And depending on how you can simplify and answer the question, stuff like that, one way might be better than the other. The next one is the quotient rule. And that basically just states if I'm dividing two terms inside, I can separate it with subtraction. And then my third rule is the power rule. This is the one I kind of hinted at in the last lecture. But basically, if I have anything raised to the power, I can bring that power down and rewrite this as n log base a of x. I think they use an R, I use an N, doesn't really matter. But so it can be written both ways. So if it is a coefficient, maybe it's easier to write it as an exponent. This depends on your situation. The book gives you some don'ts, so definitely pay attention to that. There is something called a change of base formula, which I did not see that on your homework either. And that would be log base b of x. If I wanted to, I could rewrite it as log of x over log of b. Your book has like the value a. I just use base 10 when I do this. This was more or less when we weren't given a calculator, how to easily calculate what the formula is. In this case, really and truly, I'm going to show you how you can actually express these evaluations in the calculator today. And then they do give us lots of word problem homework, a lot of word problem formulas for your homework. The first one is the pH scale. Which is written as the negative log of whatever your H3O plus is. Well, basically, this right here represents the concentrate. And then this would give us whatever the pH is as a total concentrate for the. Other than that, and then it gives you like a description of different things from 0 to 14 to see what's a base and what's an acid. That's more of your chemistry teacher. I'm just going to show you how you can do the math behind it. The next one they give you is the Richter scale. If you are going into geology or anything, you'll see this quite a bit. But to find out the Richter scale, when someone tells you the magnitude of a earthquake or something like that, it's calculated by the intensity of the earthquake compared to another earthquake. All right. And then the last one is the decibel scale. Same concept. You might do this in geology. You might also see this if you're a music major as well. But it's going to be 10 times the log of the intensity of what you're looking at divided by the intensity of what you're comparing it to. And really, these look like intense formulas, but they give you the information, and all you got to do is just plug it into a calculator and get the answer. So it's actually relatively super easy, like most of our word problems. But we're going to be on page 496. That's pretty much all that the lesson or the section was talking about. So we'll look at number 1 to start. And it says take log base 5 of 125x cubed, and it wants you to expand this. So the best way I show this to the students is separate this by everything that's being multiplied. So I can see that I have two things that are being multiplied. So I'm going to write log base 5 2 times, one of them having each one of them. Since I'm multiplying, that means I would add. Notice the base stays the same. And now you want to simplify. Here is where a lot of students will get the wrong answer a lot of times, is they forget to simplify 125. So 125, hopefully you've done it enough in the exponential functions, but hopefully you see that this is actually 5 times 5 times 5, which can be rewritten as log base 5 of 5 cubed. And then we have this guy right here. And then what happens is these two exponents have to then be put to the front as coefficients. So then I get 3 log base 5 of 5 plus 3 log base 5 of x. And then if you remember from yesterday or the last lecture, whenever you end up watching it, a base and the value here, this right here equals 1. So then you get 3 times 1, which is just 3. So this is what your homework answer is looking for when you expand it. So you expand it, but you also simplify it as well. All right, let's look at another expanded one. So let's look at, this is going to be the natural log of x squared y over 3. And so what happens here is I have 3 terms, 1, 2, 3. So I'm going to write natural log 3 times. So I have natural log of x squared being multiplied. So that's going to be a plus natural log of y. Now I'm being divided. So now I'm going to subtract the natural log of my 3. And then when I'm simplifying this, the only thing I have to do is take any exponents and make them coefficients. And there you go. So anything that basically, if you would have multiple terms on the bottom, you would just keep hitting the subtraction sign to indicate that everything's still going to be on the bottom of the fraction. If you were to divide here and then multiply something here, then it would change back to an addition, just in case you ever see something like that. Next one we'll look at is number 21. We're going to now condense this. So we just expanded it. So now we're going to condense. So this is going to be the log base 5 of x squared minus 25 minus log base 5 of x minus 5. So to condense, that always means I'm going to write the log base 1 time. And then subtraction means that subtraction on the outside of the logs, not the inside, means I'm going to divide. So what actually ends up happening is you end up with x squared minus 25 over x minus 5. Biggest mistake here, students will try to divide inside the logarithm, and it's only this sign that you actually have to divide. Now, they do want you to simplify this, so they want you to factor that one out. So x squared minus 25 is a difference of squares and ends up being x minus 5 and x plus 5 over x minus 5. So then you'll see the x minus 5's cancel. So your ultimate answer is log base 5 of x plus 5. And that's the most condensed version. Let's look at another one. Let's look at number 25. Number 25 is the natural log of 3 plus the natural log of p minus 2 times the natural log of q. Any coefficients, you're going to make exponents. Again, you're condensing, so I'm going to write natural log one time, and I'm just going to kind of work it out. I see 3, plus means times, p, minus means divide, q, coefficients become exponents, so it becomes squared. And that's it. And again, if you would have changed it back to plus, then that would go on top. And if it would have stayed on minus, then the results keep staying on the bottom. All right, so that's how you expand and condense. The next part of your homework is to be able to evaluate these expressions. We don't have an easy way to simplify this like we did in the last section, so we need to be able to condense this. Now, I was told my calculator works now, so we will verify that here in just 1 second. And it does not. And I did everything they told me to do, so I will reach back out to them. And that's very unfortunate. All right, so with that said, to do log base 4 of 17, you have 84 steps in the book, but for the Inspire, you would, let me go grab one. It's going to be, I'll just write the commands, but it would be control. And then the button that looks like this, it'll produce the log that's right above it. It'll be like in a different color. Say like log or something. And then you would be presented with something that looks like this. It'll be log with a square and then a square. So you'll be able to put the 4 here and the 17 here. All right, and when you do that, it says, I believe on the homework, I think it says round to 2 decimal places. So in this case, that would be 2.04. And that would literally be all you have to do. And you can use Desmos or whatever whatever calculator you like. Just frustrated with that calculator because they told me it was working. So I'll have to try it again for the next video. So I'll take log 1/5 of 626. Again, you would plug it in just like this. And when you do, you get negative 4.0009. So I'm just going to say 00 to kind of put it out there as stating that I'm accurate up to that point. All right. And that's pretty much it on that part. Then it gets into the word problems, and it's basically just trying to pick the right formula and just plugging in the information. So we'll look next at number 94. So on that one, it says a certain brand of tomato juice has a H3O plus, which is the concentration of 6.31 times 10 to the negative 5th power. So again, that's pretty much your concentration here. And the formula, if you go back to the beginning, is this going to be negative log of that. So this will be negative log of H3O plus. So all I'm going to do is take this value and plug it in. So my answer is just going to be whatever negative log of 6.31 times 10 to the negative 5th. Now, if you're trying to put it in the calculator here, if you leave it blank in that little square there, the calculator will know that it's a 10. or you can plug in a 10 if you would like. So you can leave it blank or put a 10 in that little spot there. And also, too, to make that 10 to the -5 power, if you just hit that 10x button without hitting control, then you will get that 10 with a little space there as well after you hit the times button, and it'll do it for you. Or you could just hit 10 raised to the -5th. And so in this case, I get a pH level of 4.199, so that'd be 4.20. All right. So again, rounding to 2 decimal places, but that 0 to indicate that that's where I rounded at. But that would be the concentration of tomato juice, 4.2. And that's really all you would have to do. So let's look at another type. Let's look at number 96. Number 96 says, what is the concentration? So we're looking for the H3O plus when in lemon juice with a pH of 2.1. So basically, again, this was pH. So it gave me the pH. So it said pH is equal to 2.1. So I'm going to plug that in and I get negative log of something equals 2.1. So if you recall from our rules from last week, we had it was a to the power of y equals x. You can go both ways as log base a of x, yeah, equals y. So there you go. So this can go both ways. So this right here is a 10, and this is a negative. So what I'm going to actually do is take this negative and bring it over here as a -1. So I write this as 10 raised to the y, so that's 2.1, equals this as a -1. So if you recall that this right here just simply means 1 over this. So if I just switch these two places, basically you're multiplying by H3O plus and then dividing by 10.1. So you're just switching the two. So we see that H3O plus will then equal 1 over 10 to the power of 2.1. And so there's your formula there. So in this case, I get 1 over 10 raised to the 2.1. And I get a concentration of 0.007943. On your homework, it's going to want you to write that as scientific notation. Now, I don't recall if we did that in this class or if you learned that prior to this class, but you would basically move the decimal until it's between a number that's between 1 and 10, which is 7. So the answer becomes 7.94 because it only goes to 2 decimal places times 10. If you went to the right, it's going to be a negative value. If you would have gone to the left, it would have been a positive value. So I went 1, 2, 3 times, so it becomes -3. So in this case, the concentration of this lemon juice would be 7.94 times 10 to the -3 power. And if they ask you for the units, I forgot to write this in the first thing, but it's moles per liter. Right? So a little bit of manipulating using all the rules that we've used so far to kind of calculate what that concentration was. But once you have this kind of formula right here, you can pretty much just always plug it into that one too. All right, let's look at some more options that you had. You had number 97, and it was talking about an earthquake in Chile in 2019 measured a 6.7 on the Richter scale. What was the intensity relative to a 0 level earthquake of this event? So basically what we do is to find the intensity here. The Richter scale formula was R equals log of your intensity of what you're looking at versus what you're comparing it to. And it says, what was the intensity relative to a zero level earthquake of this event? So you were given the Richter scale of 6.7 equals the logarithmic of whatever that intensity is. So basically, I'm just going to call it just I in itself. So from there, I'm just going to solve it. So I don't have to worry about the I0 because it's just a zero level. So this ends up being 10 raised to the 6.7 equals whatever that intensity level is. On the next one, I'll show you when you actually have some other than zero as the level. So in this case, that's just going to be 10 raised to the 6.7. And your calculator will give it to you as 5.01187 e to the sixth power. So what you need to know is that this means 5.01187 times 10 to the sixth power. That's what e is. And so what that means is I'm going to move that decimal 6 times to the right. So 1, 2, 3, 4, 5, 6. Now you might be saying, well, you just say go to the left. That's if you're going from a number to a scientific notation. I would then go to the left to do that. No, it's positive. So in this case, that's going to be 5.01187. So the intensity here would be 5,011,870 times stronger or intense. All right, and that's kind of how you do it that one when the what you're comparing to is a zero. Now 98 kind of goes with this number. So with a 98, you're then asked how much stronger was the 2001 Gujarat earthquake, which is 6.9 on the Richter scale, than the 2019 earthquake described in 97. So basically what we have here is we actually have a intensity. So what we'll do is basically you'll do log of the one you're comparing to, which is the 6.9, divided by the one that you are looking at, which is the first one, which is 6.7. So in this case, this ends up being the I0, and this ends up being the I. So then all you got to do is just plug that into the calculator. Oh, no, I'm going thinking too hard here. So because you have all the results, I actually don't need log at all, and I can just compare it this way. Because you have the intensities. So you don't even need the log. So you just do 6.9 divided by 6.7. And that would tell you that you have a 6.9, right? At 6.9 to 6.7. No, hold on. There we go. So to find the intensity of the 10.6, then I would have to divide the two results. So kind of just looking at this, using the 6.9 to the log of the intensity, and then I'll compare the two. This would then become 10 to the 6.9 will give me whatever that intensity is. So that's 10 raised to the 6.9. Which actually gives me 7.94328 times 10. Well, it says E. So I'll write it like you see in your calculator. E to the 6. And remember, that just means 7.94328 times 10 to the 6. So that's 1, 2, 3, 4, 5, 6. So that's going to be 7.94328 So now that you have these two, then you just divide them. So then you'll take 7, 9, 4, 3, 2, 8, 0 over 5, 0, 1, 1, 8, 7, 0. Or what you could do too is just say 10 to the 6.9 divided by 10 to the 6.7. Either one would work, because it would be the same answer. And we get approximately, it looks like 1.58 times. So that was the intensity level, was 1.58 times. So in reality, when you're just comparing these, you could go again and kind of skip to a formula like this, because that's how it's kind of built. All right, so that was number 98. Two more on the sense of looking at the decimal one. So 99. The decimal equation for this one is D equals 10 times log of the intensity of what you're looking at to what you're comparing it to. And it tells you a construction worker operating a jackhammer will experience noise with an intensity of 20 watts per minute if it were for ear protections. Given that I0 is 10 to the negative 12 watts per meter, what is the decimal level for such noise? So you would just say 10 times log of what you're looking at, which in this case is 20, divided by your protection of your ears, which in this case is the 10 to the negative 12. And then you just plug that in. And you get 133. So that would be your decimal level. All right. So then the next one's pretty similar to that one as well. A microphone picks up the sound of thunderclap and measures its decimal level as 105. This time it gives me the D. And then given that I0 is 10 to the negative 12, we just got to calculate the intensity. So this is log of I over 10 to the negative 12. You can go different directions here. I'm going to isolate the log so I can convert it into an exponential. So 105 divided by 10 is 10.5. And then from here, I'm going to say 10 raised to the 10.5 is equal to I over 10 to the negative 12. So then this becomes 10 to the 10.5 times 10 to the negative 12, because I would multiply both sides by 10 to the negative 12. And that would give me my intensity level. So I'm going to plug that in. And that looks to be like a decimal level of 0.03. Mm-hmm. So there you go. And that's pretty much all you got to do is just kind of plug it into the formula and to just use your rules that we've learned in the last two sections on how to solve. If at any point you need more examples, just keep emailing me. Other than that, I will see you in the next video. Bye for now.